Inequalities lesson 1 is going to deal with graphing inequalities on a coordinate plane. In order to do this, 3 steps that we'll need to follow. The first step is make sure and arrange everything is in slope-intercept form. So that is your y equals mx plus b form, or it would be f of x equals mx plus b form. That's the form it needs to be in. That's the first step. Step 2 is a critical step. It says graph the boundary line. Remember when we talked about the inequality sign itself, greater than and less than, open circle, greater than or equal to, less than or equal to, closed circle, values included, values not included. Same purpose. You will use a solid line when you have these symbols, less than or equal to, or greater than or equal to, stating values are included. You'll have a dotted line when you have less than or a greater than symbol. Third step with the inequality is you need to shade a region. There's 2 ways you can do shading. When you have things in slope-intercept form, so when you have y equals the rest of your equation, if you are using less than or equal to signs, you would shade below the boundary. When you have greater than or equal to, you shade above the boundary. The other technique you can use is called testing a point. So you pick a point, an ordered pair. I usually like to use 0, 0 if it's not going through the origin, and that'll help you determine your shading as well. So here's our first example. We have y is less than or equal to 1/2 x minus 3. This is in slope-intercept form, so we can go ahead and plot and graph right away. What I like to do is go ahead and pull out my slope and my intercept. My slope is 1/2. My intercept is -3. So I'm going to go ahead and plot my y-intercept. There's -3. From that point, I would use my slope. Your slope is positive, so your line should increase. And your slope is rise over run. Rise over run. So up 1, I would go up 1 over 2, plot. Up 1 over 2, plot. Or I could go from this point and I could go down 1 over 2, plot. But once I get a bunch of plots on there, go ahead and you could use a straight edge here to connect these points. But you have to determine, is it a solid line or a dashed line? Now if we look at this sign is less than or equal to. And if you look back at your chart, less than or equal to says it has a solid line. So I would go ahead and use a straight edge, construct a solid line. There's what my inequality looks like graphed. That would be step 2. Your third and final step is to go ahead and do your shading. Now if you look back on your table says when you have signs that are less than or equal to, you shade below the boundary line. So if I look back here, I have a less than or equal to. That is below the boundary line. So below the boundary line would be down here. This is where I would shade my inequality. All of this shading shows is those are all possible solutions that make your inequality true. You can also use test point. And I'll show you test point here on maybe the next example. Actually, I can just show you real quick on this one. So here's your equation. Y is greater than or equal to 1/2 x minus 3. Pick a point anywhere on your graph that the line does not cross. So I'm going to go ahead and I'm going to say I'm going to use 0, 0 as mentioned. I'm going to put 0, 0 into this equation here. So I put in 0 for y less than or equal to 1/2, 0 for x minus 3. I would have 0 is less than or equal to -3. This here, 0 is not less than or equal to -3. Not true. So if this is not true, I don't shade the area where I have it filled in. And here's that test point that I chose. That point is not true. That point is above the boundary. So if it's not a true above the boundary, you would shade below the boundary, as we already have done, because we used the other theory or the other method to do our shading. Example 2. Again, y is less than or equal to -7/2 x minus 5. Pull out your slope and your intercept. Pulled out my slope and intercept. Go ahead and use your intercept. Your intercept, -5. So I'm going to go ahead and plot -5. From that point, I'm going to go ahead and use my slope. My slope is -7/2, so this line should decrease. So I can go, this is my rise here, 7. So I'm going to go up 7. So I went up 7. And when I go up 7, I need to go over 2. So I'd come over 1, 2. Here's my plot. Second step, after you graph it or get your plots on your paper, is determine what type of line this needs. Well, that's determined by your inequality. Less than or equal to, solid line. Step 3, go ahead and figure out where you need a shade, above or below the line. And you can use a couple different techniques. Well, this is already in slope-intercept form. When it's in slope-intercept form and it is a less than or equal to, you shade below the boundary line. So here's below the boundary. I shade everything over here. These are all possible solutions. Or you could use your test point. As mentioned, for test point, I like to use the origin if it's open, and it is. So there's 0, 0. Put 0, 0 into this equation. I have 0 is less than or equal to -5. This again is not true. So if it's not true, I don't shade the side where this plot is. And here's where that plot was. So I shade on the opposite side, and this would be this side as we've already shaded again. Last and final example, example 3. Why don't you go ahead and give it a shot. Step 1, pull out that slope and intercept. Come up with your plots. So pause the video and then check back in. There's my 2 plots. Next, I look to determine what type of line, and this is a less than. A less than sign would have a dotted line, so your line is dotted. And dotted lines indicate that everything on that line, those values are not included. So now we got to go ahead and figure out where do we need to shade. It is a less than symbol. Less than symbol is below the boundary. So here's below the boundary again. Or you can use that test point. I could use 0, 0 again. I could put in 0 up here. 0 is less than, put in 0 for x. 7/4 times 0 is 0 minus 3. Is 0 less than 3? No, it's not. So this here is not a true statement, so I wouldn't shade on that side of the boundary. I'd shade below again. This will conclude lesson 1 on inequalities.